Okay, question 3 has given us an algebraic fraction. It's stated that x can't equal -1. That's so that the denominator of this fraction isn't ever 0. It wants us to differentiate it. So that's just going to be the quotient rule. It's a fraction, so we're going to use the quotient rule, which, if you've forgotten, is u-v minus uv dash all divided by v squared, where this is u and this is v. So we differentiate the top one, which is going to be 10x plus 10, and we multiply that by the bottom one, so just timesing that by x plus 1 squared, minus differentiating the bottom one, so v dash, which we're going to need to use the chain rule for, but that's going to be really straightforward. Bring the 2 to the front, take 1 off the power, so that's just going to become a 1, and times by the derivative of the bracket, which is just 1 as well, so it is just 2 bracket x plus 1, and then we need to times that by the u, so we need to times that by the numerator. And we also need to divide by the square of the bottom, and when we square a square, that becomes power of 4. Okay, so then we need to start simplifying this to get this just a value on the top. We can simplify this. This has got a 10 factor in common. So if I take out this factor of 10 from here, that's going to be 10 lots of x plus 1 times the x plus 1 squared. I'm trying to avoid having to expand everything out. And then over here we can take out a factor of 5x. So that's going to become 10x bracket. Then we've got the x plus 1 here. And if I take out 5x from here, I'm going to have an x left there and then a 2 there. And if you notice now, there's an x plus 1 term in both of these. So I can take a 10 bracket x plus 1 out as a factor of the whole of the top. So that's come out of here, which will leave me just with x plus 1 squared. And then when I take out the 10x plus 1 from here, I'm going to have x and the x plus 2 left. And that's good because that's going to now allow me to cancel one of the x plus 1s from here. So this will go, and this will become a 3. Then we've got the 10, and now I am going to have to expand this. So then we've got the 10, and then x squared plus 2x plus 1, minus x squared, and minus, again negative, 2x, over x plus 1 to the power of 3 now. And if you look at the bracket up here now, we've got a few more cancellations. The x squareds are going to cancel and the 2x's are going to cancel. So actually we've just got 10 times 1 on the top. So that's 10 over x plus 1 cubed. So if you go back to the top, it says so that dy by dx equals a over x plus 1 to the power of n, where a and n are constants to be found. So we've done that. A is our top number, that 10, and n is the power, which is 3. Okay, part B then says that deduce the range of values for x for which the gradient is negative. So when is 10 over x plus 1 cubed going to be negative? Now if you think about when fractions are negative when either the top or the bottom are negative, but not both. So the top is always positive in this case because 10 is a positive number. So this will be negative. The overall value of the fraction will be negative when x plus 1 cubed is negative. So it's not as difficult as it seems, this one. It's not like we don't have to worry about multiplying both sides by x plus 1 cubed, which wouldn't work anyway because we'd just get 0. We don't need to worry about timesing by a negative and flipping the sign around or anything like that. We just needed to think about the fact that the bottom needed to be negative, and And if the bottom is negative, the cube of the bottom is negative. When you cube a number, it's only going to be negative if the number was negative, which means we can say that x plus 1 needs to be negative, which means x needs to be less than 1. Which means x needs to be less than negative 1, sorry.